Welcome to Ms. Taylor's class notes. Today we're going to talk about conditional and biconditional reasoning. So conditional statements are the backbone for us creating proofs in geometry. Our conditional statements are typically how our postulates and theorems are written, and so it's important that we understand how these work so that we can use them in our postulates and our theorems. So a conditional statement is written as an if-then statement. So when we talk about symbolic form, we're talking about P, if P, then Q. So again, we read that as if P, comma, then Q. So if we look at our examples, we have our P, which is going to be our hypothesis if it is raining. So if it's raining, then our conclusion is that we need an umbrella to protect ourselves from the rain. So our if equals our hypothesis, the thing that we think is true, and then the then is our conclusion, the thing that we know because our hypothesis has happened. So we're going to be looking for our if-then statements here. So the word if is literally the thing that we look for, and then we go all the way to the comma, then we find our then, and then we go all the way to the period. So our hypothesis in this statement is you live in Nashville. So we know that people that live in Nashville also live in Tennessee. Let's capitalize Tennessee because it is a state, and I'm going to abbreviate it. And we know this is true because Tennessee is the state and Nashville is a city inside the state of Tennessee. So again, we're going to come to our if 2x plus 7 equals 1, then x equals -3. So our hypothesis is 2x plus 7 equals 1. So we can solve this equation. We can subtract 7 and get -6. We can divide by 2, and that gives us -3. So we know that x equals -3. So when we have to write our own conditional statements, our if statement is going to be our vocab word. Our then statement is going to be the definition. So if we're looking at this problem here, an obtuse angle is going to be our vocab word. Our conclusion or our then statement is going to be the definition of it. So if we write this into an if-then conditional statement, if an angle is obtuse, comma, then its measure is greater than 90 degrees. So again, our vocab word is going to be our if statement. So here in this statement, acute angles is going to be my vocab word, and 30 degrees is going to be my definition. So if, let me capitalize that, an angle is acute, comma, then its measure is 30 degrees. So this is how we write it. But one thing that we're going to do here in a second is if we analyze this, is this a true statement? Are all acute angles 30 degrees? And our answer is no, this would not be true. And so we're going to talk about that more later, but if that's the statement we're given, that's how we write that conditional statement. So the next thing we need to talk about is negation. So negation simply means not. So it is the opposite of the original statement. So the way that we write this is we're going to write a squiggle, which stands for not, and then not P. So again, we read this as not P. So if we were to write each of these statements as a negation, we would write the ball is not red. In our next statement, it says the cat is not black. So if it's not black, then we know that the cat is black. And so if it's already negated, if we negate it again, we make it true. Oh my goodness, work for me. So once we have a conditional statement, we can turn a conditional statement into other statements. We can turn it into the inverse, the converse, and the contrapositive. So our inverse is our not statement. So it is formed by negating the hypothesis. So when we're doing algebra, when we're solving equations, we do the opposite or the inverse operation. So we do the not operation. So the way that we do this, the way that we draw our symbols is we're going to draw not P, then not Q. So not P, then if not P, then not Q. Next, we have our converse. Our converse is switch. So we are going to switch. It's formed by switching. It's T-W-I-T-C-H. Switching the hypothesis and the conclusion. So we're going to write our Q first. If Q, then P. And our contrapositive is going to combine the two. It's going to be a not switch. So we're going to negate and we're going to switch the hypothesis and the conclusion. So it's going to be not, if not Q, then not P. So now let's look at this in action and let's look at it in real life. So here we've got our if statement. If it is Saturday, that's our hypothesis. Then we have our conclusion, there is no school. So this is our P, this is our Q. So the inverse means not. So we're going to negate both statements. So if it is not Saturday, comma, then, so since it already has a no in it, we're going to say yes. Then there is school. So now we've got to say, is this a truthful statement? Is this actually in fact happen? So if it's not Saturday, we have school. But I happen to know that if it's Sunday, we don't have school. And here coming up pretty soon, if it's Friday, we do not have school. So this is false because no school on Sunday. And yes, I know some people have Sunday school, but that's not the kind of school we're talking about in this if-then statement. So our converse means switch. So we're going to switch the P and the Q. So we're going to say if there is no school, comma, then it is Saturday. So now we've got to decide, is this a true statement? And again, no school cannot only be Saturday. It can also be Sunday. It can also be Fridays here coming up pretty soon. So again, false. No school on Sundays. So now we're going to do the contrapositive. We're going to do not and switch. So with the contrapositive, we're going to switch it and we're going to add a not. So if there is school, because again, negating means that we're going to make it a yes statement if it already has a no in it. If there is school, come on, pencil, comma, then it is not Saturday. So I have never had school on a Saturday, and I don't know if you've ever had school on a Saturday, so we know this is a true statement. Oh, I completely misspelled true. It's a really bad morning. All right, so the last and final thing we're going to talk about are our biconditional statements. So biconditional means that the statements are, biconditional statements are true when both the conditional, and again, conditional is P, then Q, and the converse, which is not, the converse, which is Q, then P, are true. So the way that we write this is we write P in a double arrow because it goes both directions, then Q. The language that we use is P if and only if Q. So they're going to give us a conditional statement, or they're going to give us a statement here. So 2 angles are congruent. Okay, so congruent angles is my vocab word. Definition is they have the same measure. So we're going to write this as a conditional. If 2 angles are congruent, comma, then they have the same measure. So that would be our conditional statement. So they've already given us the biconditional. That's where the if and only if comes from. That's how we know it's a biconditional statement. So now we need to look at the converse. We need to switch them. If, let me capitalize that, 2 angles have the same measure, comma, then they are congruent. So now we got to look at both statements and decide, are they true? So if 2 angles are congruent, they have the same measure. That is, yes, true. If 2 angles have the same measure, then they are congruent. So yes, both statements are true. So this is a true, T-R-U, biconditional statement. All right, I want you to turn this into a biconditional statement and tell me the truth value and check it with the class notes.